This lesson is on multiplying polynomials. Now we've done work where you multiplied monomials, and if you remember your power rules, you add your powers. This was a monomial times a monomial. Mono means one, poly means we have more than one term. So we're going to take things that have more than one term and we're going to multiply them together. Okay, so we're going to start with this one, number 1. And the parentheses for the 2p sitting out front should make you think about distributing. So we're going to distribute the 2p, but remember your power rules. When you multiply, you add your powers. So 2p times 3p is 6p squared. Remember, because these are ones. Then 2p times negative 1 is going to be a minus 2p. And I don't distribute the 2p to the 6 because the 6 isn't in parentheses. So I just bring down the plus 6. Okay, before you walk away, you have to go back to your answer and see if you have any like terms that you can add. And I don't because, these two both have p's, but they have different powers. So they're not like terms. So this is my answer. Also notice on this answer that your powers are in what's called descending order. It starts with p squared, and then it goes p to the 1, and then it has your term that doesn't have a p in it. That's called descending order, and that's how a lot of your multiple choice answers are going to appear. Okay, looking at number 2, I've got two things I'm going to distribute. I've got this 4, and if you look in the middle, now remember that's not a 2x, that's a negative 2x. So I'm going to take the whole negative 2x and I'm going to distribute it. So you got to watch your numbers, you got to watch your variables with your powers, and you've got to watch your signs. Okay, so let's start here with the 4. So 4 times 2x is 8x, and 4 times a positive 5 is a positive 20. Okay, again, I'm distributing a negative 2x. So negative 2x times x. Remember, those x's have powers that are ones, and when you multiply, you add your powers. So negative 2x to the second. And then negative 2x times a negative 1. Well, negative times a negative is a positive, and 2x times 1 is just a 2x. Now, before you walk away, we need to get it in descending order, and we need to see if we have any like terms. Okay? So I'm going to call the guy with the highest power, I'm going to call him the queen bee. So there he is. So because he has the highest power, that's our queen bee. He gets to go first. So negative 2x squared. Okay, then my next highest power are going to be my x's that have a 1. I also have 2 of them, so I'm going to add them together. They're both positive, sign to the same, add and keep your sign. So positive 10x. Now I want to point out, it's not 10x squared, because when you add, you don't touch your powers. Y'all have been doing that for years. An 8x plus a 2x is just a 10x. The multiplying where you add your powers, this part right here where you're multiplying these two and you add your powers to get that 2, that's new. But just the adding like terms, that's same old, same old. And then I've got my plus 20. The number one mistake is people will distribute and they'll get this right here, and then they'll walk away. They think they're done. But you always want to get it into descending order, and you have to add your like terms. It's that cleaning up before you walk away. Okay, now number 3 is 2 terms times 2 terms. There we go. Okay, so this is teachers call this different things. They'll call it FOIL. Sometimes I'll refer to this as a lobster, and I'll explain why in a second. The FOIL is first, outer, inner, last. Okay, watch. First times first. Outer, so outside times outside. Inner inside times inside, and then last, last, last. And when you do this, you're distributing, so you're multiplying. Okay, another way you can think of it is I'm going to take this x right here and I'm going to distribute him to both of these. And then I'm going to take this positive 1 and I'm going to draw my lines underneath because otherwise I think it gets all jumbled up. I'm going to take the 1 and distribute it there and there. Now I call this lobster because I think it looks like lobster claws. So if you hear me call it lobster, that's what I'm talking about. I'm talking about foil or distributing. Okay, so let's do this one more time. I'm taking the x and I'm going to distribute him to both the guys in the other parentheses. And then I'm going to take my positive 1 and distribute him. And when we distribute, we multiply. So x times x is x squared. X times negative 4, watch your signs, is a negative 4x. 1 times x is a positive 1x. Don't have to have the 1 there if you don't want to. Then the positive 1 times the negative 4 is negative 4. All right, you're done with your lobster. Can you walk away from this problem? No. We are in order. We got my queen bee right there, highest power. But if you'll look in the middle, I have like terms. So I'm going to bring down my x squared and I'm going to combine my like terms. Well, it's a negative 4x and a positive 1x. So signs are different. Subtract. Take the sign of the bigger number. So that's a negative 3x. And then my minus 4 comes down. Okay, let's look at number 4. Okay, again, this is a lobster. I'm going to erase this so I have some room. I'm going to take this x and I'm going to distribute here and here. And then I'm going to take my negative 6 and distribute here and here. Okay, so x times x is x squared because when you multiply, you add your powers. X times a positive 6 is a positive 6x. Negative 6 times x is a negative 6x. And a negative 6 times a positive 6 is a negative 36. Again, don't walk away too soon. I've got my x squared term in the front. I like that. My middle two terms, they're like terms, so I can combine them together. Here's the question. What happens when you combine them together? They cancel. They cancel as in like they're gone. I don't have any x's left. Don't put an x here because if you do, you're telling me you have an x left over. They completely cancel. They're gone. And so then I have my minus 36. So how is number 4 different from number 3? Well, when we got to the middle two terms of number 3, they didn't cancel. That gave me x squared minus 3x minus 4. I had this middle term in my final answer. Well, on this final answer, I only have 2 terms. That's because my middle 2 terms canceled. Okay, so let's think about it. Go back and look at the original problem. Could you look at number 4 and tell that your middle 2 terms were going to cancel? If you have x plus a number times x minus the same number, this part right here should always happen. Now notice in number 3, I have a plus and then a minus, but are these numbers the same? No. So when I go to do this middle step, I have a leftover answer. So as you do these, and this is going to help when we get to factoring too, as you do these, see if you can keep your eye out for these. And when you get to one where everybody cancels, you can look back and say, oh yeah, it was x plus 6 and x minus 6. It makes sense that they canceled. Or maybe you can catch it on the front end of the problem and say, ooh, they're the same, but one's a plus and one's a minus. I bet when I get to this step, they're going to cancel. So you can look for it to happen. Okay, so let's look at number 5. Do you notice anything? This is an x plus 1 times an x minus 1. The exact same parentheses, but one's a plus and one's a minus. So this is where we should be looking for the middle two terms to cancel. Okay, so let's lobster. X times x times negative 1. So x times x is x squared, and x times a negative 1 is a negative 1x. Okay, now do the bottom lobster claw. 1 times x, positive 1x, positive 1 times a negative 1 is a negative 1. I bring my x squared term down. My middle two terms are like terms because they both have x's. But what's going to happen when you do negative 1x plus 1x? They are going to cancel. And I was ready for that to happen. And then I have my minus 1. So this answer only has 2 terms in its answer because the middle two terms canceled. Okay, now let's look at number 6. Is that going to happen in number 6? No. I do have 1 plus and 1 minus, but I have a 9 and a 5, and they're definitely not going to cancel. So this is a full-out lobster, and those middle two terms are not going to cancel. So here we go. X times x, x squared. X times negative 5, negative 5x. 9 times x, positive 9x. You got to really, really, really watch your signs here. Positive 9 times negative 5 is a negative, because your signs are different, 45. Okay, I got my x squared. These two terms are like terms because they both have an x and they're both to the first power. I have a negative 5 and a positive 9. That's going to give me a positive 4x minus 45. And my answer has 3 terms. I have that middle term because these two did not cancel out. Okay, so number 7 is them trying to be sneaky. They are really hoping that you look at this like, you know, a week ago when we were doing this and we were focusing on just power rules, a power to a power you multiply. So that gives me x to the 6. But this is a monomial, one term, and those rules only apply to monomials. This is 2 terms. So when you square this, you can't just square the x and square the 5, but I guarantee you that will be an answer and that will be an answer. Both of them. And they are wrong. Those are dummy answers. You cannot just square them both and leave them where they are. Okay, well, if 3, 4, 5, and 6 were lobsters, I'm going to call this a lobster that's like hiding under a rock. And if you step near him and don't see him, he's going to pinch your toe off. This is a lobster. What this squared means is that you have 2 of them. So I want you to write it again. And that shows you, that's like pulling the rock back and saying, okay, lobster, I see you. You're not going to pinch my toe off. I got x minus 5 times x minus 5. So now you go full on lobster. X times x, x squared. X times negative 5, negative 5x. Negative 5 times x, watch your signs, negative 5x. Negative 5 times negative 5, a negative times a negative is a positive. Okay? Do those middle two terms cancel? No. Your signs are the same. They don't cancel. They only cancel when one's a positive and one's a negative. So I have my x squared. A negative 5x and a negative 5x is a negative 10x plus 25. So this, when it's only written once and it's squared, is a lobster hiding under the rock. You pull the rock back, write it twice, and then go regular lobster. So it doesn't pinch your toe off. Okay, number 8. Again, this is a lobster hiding under the rock. So I'm going to mark out the 2, and I'm going to write it twice. And then I see the lobster. So here I go. M times m, m squared. m times 1 plus 1m. 1 times n, m, 1m, and 1 times 1. Like terms in the middle. And again, these did not cancel. They are the same, but they don't have opposite signs, so they don't cancel. Okay, now we've got a little bit more meat on them. Process is exactly the same. Here we go. 2x times x. 2x times x. Multiply your numbers, add your powers. So 2x squared. Then 2x times a negative 7. So negative 14x. Negative 4 times x. Negative 4x. Negative 4 times negative 7. Positive, because a negative times a negative, 28. Okay, so 2x squared. Now, these are like terms because they both have an x. The signs are the same, so I'm going to add and keep the sign. So negative 28x plus 28. The process is identical. The numbers just have more meat on them. That's it. Okay, so let's check out number 10. So I'm going to take the 3x and I'm going to multiply it by negative 2x. So 3x times negative 2x is a negative 6x squared. Then a 3x times a negative 1 is a negative 3x. Positive 5 times negative 2x is a negative 10x. Positive 5 times negative 1 is a negative 5. Queen bee, like terms, signs are the same, add and keep the sign. Negative 13x minus 5. Okay, so here is an application of multiplying polynomials. Find the area of the shaded region. Okay, I want you to think of this like a rectangular donut, not a cream filled. It's got the hole in the middle. Okay, can you picture it? What I want to do is I want to know how much donut I'm getting. Okay, well, I need to find the area of the whole thing, and then I'm going to subtract out the area of the hole because there's no donut there. I can't count that. Okay, so now stare at the rectangles. Area. How do you find the area of a rectangle? It's length times width. Area of a rectangle is length times width. Okay, look at the outside edge of this donut. Okay, the length, 2x minus 6, and the width, x plus 4. These guys are in the hole. I'm not interested in them right now. I'm doing the outer edge. Okay, so I'm going to do 2x minus 6 times x plus 4. That's length times width. Okay, well, this is a lobster. Okay, here we go. 2x squared plus 8x minus 6x minus 24. Queen bee, like terms, signs are different. Subtract, take the sign of the bigger number. Okay, so this, what's right here, is the big. It's the area of the big rectangular donut. Okay, so now what I've got to do is I've got to go find the area of the hole, the H-O-L-E, the small. Okay, so the area of the small rectangle is going to be x plus 9 times x plus 1. And you could do the x plus 1 times x plus 9. It doesn't matter. You're going to get the same answer either way. The order does not matter here. Okay, so then I distribute It's going to give me 1x plus 9x. 9 times 1 is 9. Queen bee, like terms. Okay, so this is the area of the part of the rectangle where there is no donut. So he is the little. Now to figure out how much donut I've got to take the big, which is the whole rectangle, and I have to subtract out the little because I don't have any donut there. So here's what I'm going to do. I'm going to do big minus little. Okay, well the big is 2x squared plus 2x minus 24. Okay, minus the little, which is x squared plus 10x plus 9. Okay, now think back to, I don't know, 2 months ago, a month and a half ago. Think about what that is. That's a shark. We got lobsters and donuts and sharks all in this problem. He is a shark. And what do we do to this and all of that right there? You change this to a plus sign and you let the shark run through and change every sign. Don't forget the guy in the front. Okay, now I'm just going to add my like terms. Okay, so let's look. This is a 2x squared, and I'm going to put a 1 here just to help me. 2x squared and a negative 1x squared. Well, 2 minus 1 is 1, so that's a 1x squared. Then I have a positive 2x and a negative 10x. Watch your signs. And that's going to give me a negative 8x. And then I have a negative 24 and a negative 9. Signs are the same, so I'm going to add. Well, 24 and 10 would be 34, and this is only 9, so 33. And it's negative because I keep the sign. And that is your donut, your rectangular donut. So again, when you get to one like this, it is always the area of the big, the outside area, minus the area of the little. The area of the big minus the area of the little. You have to subtract that out because there's no donut there. There's no area there. Okay, last one. Okay, so I'm going to start out with big minus little. Okay, so who's on the outside edge? Who's the big? This one and this one. And again, it doesn't matter the order you put these in. I'm going to put the 2x plus 4 first. And I'm going to multiply it by the 7x minus 2. Okay, now let's go ahead and set up the little minus, and again, there's your shark. Who's the little? Well, the little is this times this. So 4x times x plus 9. Well, guys, that's not a lobster. That's just a regular distribute. Like, you've done that before. The big is a lobster, though. Here I go. That would be 14x squared. And that would be a negative 4x. And that would be a positive 28x. And that would be a negative 8. Now, before I move on, I'm going to clean this up. I'm staying with this lobster until it's done. So 14x squared is queen bee. Okay, those are like terms. Signs are different, so I subtract. Take the sign of the bigger number. So positive 24x minus 8. Okay, that's the big. That's the big rectangular donut. Now on this one, this is sort of like a one-handed lobster. It's like, you know, those crabs that you find on the beach where some poor kid has pulled off the pincher of one of his hands, but he's still kicking. So this is a one-handed lobster. He only has one hand. So when I distribute this, I'm going to get 4x squared, because when you multiply, you add your powers, plus, and then 4x times 9 is 36x. And that's it. That's all there is to him. There are no like terms, nothing else I can do. One-handed lobsters are super, super easy. Okay, now I got my shark. Now with my shark, remember, you change him to a plus sign and you let him swim through the second equation. So negative, negative. Okay, now add your like terms. So I have a 14x squared and a negative 4x squared. And that's going to give me 10x squared. And then I have a 24x and a negative 36x. Signs are different, so I'm going to subtract. 24 and 10 will get me to 34. So I need 2 more, so 12. And take the sign of the bigger number, so negative 12x. Okay, well, who's left? This little negative 8. Now, he doesn't have any like terms. He doesn't have any friends, but he's still a part of our answer. And there you go. That's the area of your rectangular donut. So always start them off big minus little. Find the area of the big, find the area of the little, let the shark run through, add your like terms.